Rolle's theorem is actually very simple. So let's suppose that we have a function f of x. Now this function is going to be defined on an interval from a to b, or at least we're going to consider the interval from a to b, and we're going to put the following restrictions. So first of all, we're going to assume that f of x is continuous on the closed interval from a to b. So continuous on a closed interval from a to b. And we're also going to assume that this function is differentiable on an open interval from a to b. Now let's suppose that for this function, f of a is in fact equal to f of b. Now what Rolle's theorem says is that there is such a value c, such that c is somewhere between a and b. So c is a point between a and b, such that the first derivative of the function at this point, when x is equal to c, is in fact equal to 0. So what this essentially implies is as follows. Let's actually draw a picture to kind of illustrate. So let's have the axes going like this, and let's suppose that we have some function or other just going like this. So we can pick 2 points where the value is more or less the same. So for example, we can say that there is a point here and that there is a point here. They both have the same y value, but they obviously have different x values. So that would be a and b. Now what this is saying is that somewhere down the line between a and b, we have a point where the first derivative is 0, meaning that there is a horizontal tangent. And as you can see in our picture, the horizontal tangent to the graph is right about here. I'm not perfect at drawing this, but it's going to be right about here, and there's going to be a point somewhere where this tangent is exactly flat, exactly parallel to the x-axis. So that's basically all that the Rolle's theorem is actually stating, and it doesn't really matter what your function is as long as these particular conditions hold. You're always going to have a point somewhere where this is in fact the case. Even if the function is just a horizontal line, for example, then the first derivative is at 0 at each and every point in actual fact, and the function it can take virtually any shape, and you're going to have at least one point where the first derivative is 0. So as a kind of practical example, if you consider a function, let's have f of x as, for example, 3x squared minus 6x minus 9. So you would have a function that goes something like this. So let me just very crudely draw this one. So it goes like this, and it goes through different points, let's say minus 1 and 3. So what we can say is that at this point the tangent has 0 slope. In other words, the first derivative of the function is 0. And of course we can find out that exact point by differentiating the function. So we take the first derivative, and this becomes 6x minus 6. We make that equal to 0, and we get x is equal to 1. So we know that this particular point has an x value of 1. So that's pretty much all that Rolle's theorem is actually stating.